Math journaling is something that we use a lot in this class, and this lesson is about teaching you how to create a math journal that accurately shows your understanding of a concept. And it'll show you how to demonstrate a minimally meets level of understanding, a fully meeting level of understanding, and an exceeding expectations level of understanding. And we're going to use multiplication to do this math journal. Your learning intention for this lesson: I can create a math journal that accurately displays my understanding of a mathematical concept. To briefly discuss the terms that I use when I am giving you feedback or evaluating your work, not yet within expectations means that you don't understand it. But the three that most commonly come up are minimally meets. And with minimally meets, you can do the work, you can follow the rules, but you aren't explaining or showing that you actually understand how those rules apply. So with minimally meeting, you follow the rules and you can do the calculations, or at least most of the calculations. With fully meeting, you can follow the rules and do the calculations. So everything that is above counts in here. But you can also explain how you're doing the calculations. You can show that you have an understanding of how this concept works. In the case of algorithms, it's not just being able to apply the algorithm, but being able to explain how you come up with the algorithm itself. As a quick aside, an algorithm is basically the process of rules or steps that you follow in order to solve an equation. And finally, to get an exceeding on a math journal, again, you need to do everything from minimally meets and fully meets, but you also need to be able to connect what you're doing here to other concepts, or to be able to apply the algorithm to more complex problems and explain how it solves those problems, or to explain in in a fuller way why the algorithm works the way it does with different types of questions. The problem with exceeds, of course, is that there are so many different ways of exceeding the expectations of a assignment, whether it's a math journal or another one. So these are some examples of how you could do that, but there are other examples as well, and there are other ways of exceeding the expectations on a math journal that I have not articulated today. So we're going to start with multiplying decimals. Our learning intention is I can multiply decimals of varying complexity and explain my thinking. And I'm going to show you how to get a 2 on this particular math journal. And really the way to do that is to do the multiplication of decimals for varying complexities. So I'm going to write that down. Now, doing just these types of questions is going to get you a basic 2 because you're really not showing your thinking. At least you do have these calculations here, so I can see that I can see how you're doing the multiplication, but I can't actually see the multiplication itself. Things like carrying or remembering the placeholder 0. So this would be a low 2. A question like this one, and doing a few of these, would give you a higher mark in a 2 because you're showing that you can do the multiplication, you can show where you're getting these numbers from, and you're also showing that you understand that in multiplying decimals, you count the number of decimals after the decimal. You count the digits after the decimal, and there are that many digits after the decimal in the answer. So you're showing that. So this would be a higher level 2, but you're still not explaining your thinking. In a 2-level question, I do still expect a variety of examples. some of which can be simple questions, 2 digits, maybe 1 or 2 digits after decimals, something like this. Or ones where maybe the digits are only after one number, so something like 175.86 times 21. Ones that are a little bit easier to figure out in that way. And I would expect some more complex questions, questions with no whole numbers, like in this question here. Or ones with several digits before and after decimals, as in that question. And I'd expect probably 4 or more questions of these different types. So now let's look at what I would expect in a 3 or a fully meeting response. Same learning intention, but how you do it is going to be a little bit different. In a 3-level question, I would be looking for a little more information. So it's not enough just to have the question and the calculations the way we did with the 2. It needs to be explained as well. And what I do in this 3-level response is you look at proving why the algorithm works. So this fake student started with estimation. Okay, 1.4 can be rounded down to 1, 6.8 can be rounded up to 7, so the answer is going to be somewhere in the vicinity of 1 times 7, which is 7. So my student says, my fake student says, I'm going to be looking for an answer that's about 7. Then they eliminate the decimals out of the question entirely and just do the calculations with numbers. And again, one of the important things is that they show their work. So they show how they're figuring out these calculations. And they come up with the numbers 952. And then have this little note here that the closest they can get to 7 with these digits is 9.52. And that makes sense. So this is the first answer they get. And then they go about and they do it with the algorithm and they prove that the algorithm works because when you count the digits after the decimals in the question, there are 2 digits after the decimal. You have that many after the answer, after the decimal in the answer, 9.52. So these are alternate methods, but they come up with the same answer. And what I would expect from a 3-level response is, again, probably 4, 5, 6 questions of varying complexity. These ones only have their 2 digits, their 2-digit numbers. They've only got 1 number after the decimal. I'd expect some that have a 0, 0 decimal something. I'd expect some that have multiple numbers after a decimal to show that they can do different difficulties of problems. Now a 4-level response is going to start with a 3-level response. So I'm going to see a lot of the same things. What I'm going to see differently is some different terminology and some deeper levels of explanation. So for example, here, when it says count the digits after the decimals in the question, they might use, instead of this, instead of in the question, they might use the term the factors, in the factors. Because, of course, these 2 numbers are factors. The answer is a multiple. So they have that mathematical knowledge and they can use that mathematical terminology. Another example of this is when they're calculating the estimate up here. They might say, rather than just saying that I'm looking for an answer that's about 7, they might actually identify this as an underestimate. And it's an underestimate, of course, because this number is not 1. This number is a little bit less than 7, that's true, but this number is quite a bit more than 1. So what we're looking for really is about 1.5 of 7. So I might see something that goes 1.5 times 7. So they're looking for an answer that is about 10. Half of 7 being 3.5. 3 plus 7 equals 10. So it's easier to deal with than saying 10.5. I wouldn't necessarily expect them to go to that level, although they could, but this shows a better understanding of what they're looking for in terms of an estimate. And then again, they're looking for an estimate that is as close to 10 as they can get, and 9.52 is still the correct answer. Like I said earlier, a 4-level and exceeding response goes beyond just explaining the algorithm, but also gets at some of the other things that are important when doing mathematics. And one of these things is, for this particular concept, is explaining what multiplication is, and talking about the use of logic, which in my classes I use quite a bit, or at least I talk about using quite a bit. Multiplication, as this student, my fake student here, says, multiplication is creating groups of numbers. With decimals, you're also creating partial groups. So they're showing an understanding of what multiplication is, but also how decimals work into this general knowledge of what multiplication is. It's important to use logic when looking at your answer because it helps you find silly mistakes. For example, logic tells me that my answer can't be 95 decimal 2, because even if I rounded both numbers up, which you shouldn't do, but if you did, the highest number you can get is 12. 95 decimal 2 is quite a bit larger than 12. So if I made the mistake of thinking there was only one digit after the decimal, because both 1.4 and 6.8 each only have one digit after the decimal, and here they're identifying a common misconception of students that if you have a question like the example given, 1.4 times 6.8, how many numbers are after the decimal? Some students will say there's only one number after the decimal because there is in each of these factors only one number after the decimal, when the correct answer, as we know, is 2 because there's one here and there's one here. But if they made that misconception, which again is common, the exceeding expectation answer to this learning intention identifies this misconception and explains how to deal with it. If you use logic, you can see that the answer 95 decimal 2 can't be correct, and you realize that you have a misconception, you can go back and fix it. Now again, like in the 3 and the 2-level response, I would expect multiple types of explanation or multiple types of questions in a 4-level response. Say 5, 6, or 7, where they're showing different types of combinations of multiplication in their answer. Not all of them are going to have the same detail of response. This is the first one that this fake student did, so it has more. You're not going to repeat this whole section about what multiplication is because you've already said it once and you've already identified this particular misconception, but there may be others that students commonly make with multiplication of decimals and or with multiplication in general. For example, one thing that we see is forgetting to use your placeholder 0. And the exceeding expectation response would identify some of these misconceptions and explain how someone could try and avoid them or catch them if they did them by mistake. Here are the key ideas of this lesson. The math journal, the point of it is to let your teacher know whether you actually understand the concept, not just whether you can do the questions that are put in front of you, which will help you apply the math to different problems and different situations in the future. A 2-level response just shows the number calculations. A 3-level response shows those calculations, but also includes explanations of how those calculations were made or why they're correct. And a 4-level response includes all of that, but also goes beyond, possibly through using precise mathematical language, possibly by explaining how the algorithm was developed, possibly by looking at what the next steps in this lesson or in this concept would look like, or how it ties into other concepts that the student may be learning.